Hi, my name is Colleen, and I'm an educator with the Los Angeles Maritime Institute, also known as LAMI. Our organization is partnered with our local Sea Scout group, Ship 1992, and today we are presenting two of our STEM lessons, Buoyancy and the Physics of Sailing. Now recently, our Sea Scouts have been experimenting with these concepts by building their own model boats. They're going to be making full-size vessels later on this year. So to get things going, we're going to switch over to Chelsea, who's going to get us started.
Density is a property of matter saying how much stuff, how much matter is packed into a certain space. This is a property of three-dimensional things, but I have here a convenient 2D representation. So imagine if you draw a square and you fill that square with a set number of dots. I filled my square with 100 dots. And then I drew a slightly larger rectangle on the side, and I also filled it with 100 dots. Looking at this, you can see that one of these is more dense, there's more stuff packed into smaller space than the other. This one's more dense. Now, in three-dimensional objects, I said I increased the volume. Usually it's about twice the size on paper, but it's actually 3 times the amount of space when you are considering a three-dimensional object, because we have both length, height, and width. So things that are the same size, if they are made of different materials, they can have even different densities. For boats, this is important because we make our boats out of lots of different things. And, well, we want more dense materials so that they will be more sturdy. There's another thing, however. We also want our boats to float. And when you put something into a liquid, it is going to show its properties of buoyancy. Now, things that are really dense tend not to float so well. So we have another property, and that is surface area. So even if you have something that's dense, if it is spread over a large enough surface area, that's going to allow the water to act on it with water displacement. Have you ever put something in a really, really full glass or tub or sink full of water? What happens to the water? It goes everywhere. That's because two things cannot occupy the same space. Now in the ocean, there is no otherwhere for things to go. So instead of flowing out of the way, the water pushes back on whatever is placed in it, which is how we get boats to float. Their surface area is large enough for the force of water displacement to press on them, and thus the boat floats.
We got plastic. Two things of the same volume, but if you could feel them, you would instantly tell that one of these is much more dense than the other. Yeah, no surprise there. The more dense one sinks. So we have here some different things that boats are made out of. We have here an example of wood. They are both about the same size, so about the same volume. Actually, this one is a little more voluminous. And if you could feel these, you would instantly tell that one of these is more dense than the other. So let's toss them in and see what happens. Yeah. So this is how things being lighter shows how they float. Now, most of our modern boats are made of metal. And I've got here one little piece of a boat that we had, and it's very rusty because we usually use salt water for this. So here's a nut. And I bet to no one's surprise, this is gonna sink. I have here a jam jar lid, which is also made of metal. And this one, if you can already tell that one of these is more dense than the other, just by size and shape. So one of these is gonna sink and one of these is gonna float. Yeah, but that's not fair. This one is clearly lighter. Well, let's weigh it down, shall we? I have here some pennies. Also extremely rusted, or yeah, really gross because we also use salt water and then don't always rinse them off. Yeah. So now filled with pennies, but man, how are we ever gonna make things float? Well, there's another trick we can do. We can make it bigger. Similar lid, this time for olives. But here is the same weight of the nut matching it. Let's spread out the weight so it's nice and even. And I put it in there, boom. So, because there's more area for the water to push against from underneath, we have flotation.
So that's buoyancy and density in a nutshell. Let's switch over to our Sea Scouts, and we're going to hear from Tim Nelson, one of our group leaders, who's also going to talk a little bit about the Vikings, and then we're also going to see some video of Draken, which is a modern reproduction of a Viking sailing ship that actually crossed the Atlantic a couple years ago. And then we're going to take a look at what our Sea Scouts have created.
Hi, I'm Tim Nelson with Sea Scout Ship 1992 out of San Pedro. Now, the Vikings weren't just great explorers and great warriors, but they were also great engineers. And the ships they built were truly amazing, and they were able to take them all the way across the ocean, the North Sea, over to Western Europe, not only to England and Scotland and Ireland, but down to France. And of course, they discovered Iceland and Greenland. Everybody knows that, but we also know that they've all made it all the way over to Newfoundland, Canada, where there are now been some explorations of some Viking colonies there. So these great warriors were great engineers, and these ships were truly amazing. And as I'm here in this rainy Southern California day, it reminds me of how these Viking explorers must have endured some really cold weather as they were on those ships fully exposed. They were not built to be comfortable. They were built to be fast. Now, not only were these ships built to be fast, but they were built to be mobile. These ships could make it onto a beachhead so that the warriors could get off and attack monasteries. They were able to go upriver. They were able to go up the Seine River to Paris and attack the Parisians. They went down the rivers in Eastern Europe all the way to the Black Sea, across the Black Sea to Constantinople. And at Constantinople, they went down to trade, but they also were enlisted to be part of the Varangian Guard, the personal protecting guard of the Emperor of Constantinople. And Constantinople is known today as Istanbul. So the Vikings were able to not only make it all the way over to North America, but they made it all the way down to the Middle East. And they were great traders and great explorers, and it all came down to the great ships that they designed and the great engineering that they had. And now what we're going to do is Ship 1992, our TopSailors Sea Scouts, we're going to go ahead and try to build some small Viking ships and then put them to a test and see how fast they will sail.
My boat is great because it has the mouth of a dragon, a keel to keep it going straight, and a great foundation for my mast so it will not fall down.
I designed 2 boats. I'm competing in both categories. This is for the regular category. It has to be under 12 inches. I believe in this. It's my little paddle boat. It may not have a sail, it may not have a mast, but I really think this one's gonna be a winner. This one is competing in a special category up against Lauren's boat. She might have the length advantage, but I think this is just gonna be a really reliable boat. The tape back is gonna give it a lot of structural stability, and the bow is gonna be able to just go straight through. And I like the mast design. I used a custom mast as opposed to the regular dowel.
So this is the SS Drill. I named it that because it's the only Sea Scout event I'm actually good at. So it is approximately a yard long, 3 feet, and it fills up about half of our actual route we're going to sail across. I think it's objectively the smartest idea because you can't beat a boat that's already covering half of the radius of the track. I have to go way shorter than anyone else. So I just objectively made the smartest design for a boat, and then Mr. Nelson decided that that wasn't fair play, so now he made an entire category so I couldn't compete against anyone else, which is it's not very cool because, I'm just using the rules liberally to my advantage. I don't know, everyone else thinks their boats are superior because they're normally sized and whatnot. Emmett has little rowboats, little seats in his rowboat, which is cute, but I just can't compete with something that's objectively the best design. Yeah.
This is my boat. Currently I'm working on this with a sort of catamaran-like design where it'll kind of go through and then the water will go to the sides and pass through it. Luckily, since there's an area in between here, it'll weigh less but still get the same hydrodynamics to get through. That's my main plan from it. From here I'm planning to build the sails here, balance them, put a beam between, stick it up again, and then put a flag on top of there. Or put a sail to help propel it forward evenly and not make it skew to one side or the other. Originally, I was planning to add kind of a fin to the bottom to help keep direction, but given the constraints of how deep it goes, I think it'll be wise to make a slight one with hot glue going down, or none at all. But that's my design idea for this.
So my boat, it's a secret design. I'm using some computer-aided stuff. I'm not going to tell anybody about it, but I think I'm going to win.
Before we get into the races, let's take a few minutes to talk about fluid dynamics and how sails work. So let's go back to Chelsea.
So if you look at any sailboat, you will see that there are some big upright bits called the mast, and then attached to that is a big piece of cloth, a sail. And when the wind is blowing, the sail will fill with air and belly out, make a nice round shape, and the boat will begin to move forward.
The cool thing about sailboats is that you are not limited to go just with the wind. Depending on the type of sailboat you have, you can actually point towards where the wind is coming from. The only place you cannot go is directly into the wind.
This is because of the physics principles defined by Bernoulli and the concept of lift. So why does a curve follow a curve? Why does an airplane fly? How does a sailboat go? The answer is all the same. Bernoulli's principle states that the faster a fluid moves, the less pressure it exerts. Fluid, we were just talking about air and wind. Well, something to keep in mind is that in physics, air and liquid act similarly enough that they can be treated the same way mathematically and are together referred to as fluids. As a ball, a wing, or a sail passes through the air encounters the object with different velocities and therefore different pressures. If we look at this drawing of the boat, we see that there's a curve to the sail. As the air flows across the boat, the air is cut in half by the sail. The air is going to travel at the same speed. However, when the wind splits on either side of the sail, the air on the outside of the curve, or the leeward side, is going to move faster in order to continue traveling because it has further distance to travel. This spreads the molecules of the air apart and creates a low pressure area on that side of the sail. The air on the windward side is going along the belly of the sail, and it's going to move slower because it doesn't have to go as far. So this air is more dense and exerts a higher pressure on the sail. This high pressure wants to move to the area of low pressure, which drives the sail in that direction. The result of this difference in air pressure is a net upward force called lift. Now you may wonder, how come the boat doesn't fall over? The answer is because of the keel and Newtonian physics, specifically Newton's third law, that for every action there is an opposite and equal reaction. As the boat is pushed by the wind, the water pushes back against the keel below the waterline, and that is enough force that the pressures of the wind and water nearly cancel each other out, and all that's left is that forward motion from the lift.
Now that we understand the science, let's see our scouts put their boats to the test. And we're also going to hear some commentary from LAMI's program director, Bruce Heyman.
Hello, welcome. Very excited to have you here. We're about to talk about the regatta and the boat race that we are going to see. Our contestants have been building their boats for the last few weeks, and they're now ready to enter the regatta and compete. The course is laid out before us. Let's watch as they start the first drill. We can see the first vessel is SS Drill. It's a nice long vessel. So what's happening? Very quick. So they have an extra long vessel. What does that do? That extra long vessel provides a lot of form stability. Stability that allows the boat to stay pointed straight down to the finish line. There's no Bernoulli effect or lift effect. This is purely done. Here is the fan right back here. This is what's providing the energy, and here is the sail. This is what we call dead downwind, and in this case, you just put up as much linen as we sailors often refer to our sails and let it get in the way of the wind, and the wind will push it out. The fact that the boat is nice and long and almost the width of the course keeps the boat so that it's not getting sideways in the path. This one did very well. So what's happening in this particular case? In this particular case, we can see that the vessel has gotten sideways. And the reason for that is this doesn't have the form stability that the longer one had that in the previous example. Here we can see that the vessel is much smaller than the actual size of the lane so that it can get sideways in it. And we can see that the wind source over here is blowing. Now what happens is the vessel has a center line, and around that center line, if the force is stronger on one side of the vessel than the other, then the boat's going to pivot. And that's exactly what happened. The wind was stronger on this side, so the boat pivoted. This side of the boat started to go faster, and this is called yawing, and that's what caused it to hit the side here. So now we have the Norwegian Lincoln entering the race, and you can see this boat is also significantly smaller. And what happened? The first thing is the boat demonstrated two problems with stability. One, you can see that a lot of the force was up on high, and that pushed the boat over, and it's actually capsized. Now, there still is some of the boat that's above the sea, above the water. None of us would want to be on this boat right now, but the wind is continuing to blow it down. All right, now this vessel is a very interesting design in that it has no hull. So it has only a bunch of structure that will allow it to float. But obviously, water and paper for sails do not mix. They're absorbing the moisture. That's creating a lot of what we call wetted surface. And that wetted surface is going to be very slow. The hull is clearly not floating above the water. It's actually floating somewhere below the water. Why is that? Well, it's because water is about 64 pounds per cubic foot, and wood, that's probably a form of Douglas fir, and Douglas fir is only about 30 pounds per cubic foot. So it is lighter than water, and it'll float somewhere near the surface. Now, this one is probably going to do very good. It has a lot going for it. One, very stable mast. And then because of those outriggers way out in front, it offers a lot of form stability. And it's also wide enough that it cannot be ricocheting its way down the channel. All right. And now we're seeing what happens. And as you direct the fan, this one has similar. Notice that it seriously wants to turn to starboard or turn to the right, but it's balanced well enough that it can make it all the way to the end. Excellent job. All of these designers are naval architects or fulfilling the role of naval architect. They're designing. And when people ask, what is the best design of a boat? Well, there really is no best design for a boat. Boats, like many things, are all a bunch of trade-offs. Whether you're designing a boat to go really fast, or designing a boat to be really stable, or whether you're designing a boat to carry a lot of cargo and bring Christmas presents to all of us. It all makes a bunch of trade-offs. And the person that designs a boat is actually called a naval architect. They get many years of schooling, and they're a form of engineer. They are solving problems. These folks all solved a lot of problems. So we didn't have any losers today. We had a couple of winners. We actually had the Jolly Rancher, not Jolly Roger, but Jolly Rancher with the green sail that won the regular category. And then we had a new category because we had some very creative solutions. We had the irregular category, and that was won by SS Drill, that really long boat that provided a lot of stability. So like I said, we had no losers. What we had today was a couple of winners and a whole bunch of learners. So I hope to see you out there on the water, and please pay attention to STEM.
Hey guys, thanks for checking out our program today. If you have any questions, email us at asklami@lamitopsail.org, or you can go to our website for more lessons and to see our sailing schedule.
Hi, how are you guys doing? I hope you enjoyed that video. This is Tim Nelson. I'm the skipper with Ship 1992, and we are based in San Pedro, down by the Los Angeles Port Authority, down near Alta Sea, and we are a part of Los Angeles Maritime Institute's youth program. They are a academic-based program for the youth of Los Angeles. They take a lot of school children, elementary, middle school, high school kids out on their tall sail ships to teach them STEM-based programs. And we are their youth program. So we are active in building boats and understanding boats. We get out on the tall sail ships. We have to understand the way the ropes move the sails and how to adjust according to the wind. And we're excited to have you guys watch a little bit about us. I also have Emmett Nelson. He's my son. He's part of the Sea Scout program. He's on here too. We're going to answer a few questions that you guys have posted afterwards. Before we go to the questions, I just want to make one note. Today is Los Angeles Maritime Institute's 29th birthday. They were started in 1992. So happy birthday, Los Angeles Maritime Institute. It was all started by a teacher, actually a teacher who started the program, and it's all about teaching youth. So just keep that in mind. We are there for the youth of the Los Angeles area. We want to get out kids of all backgrounds out onto the sea to teach them the maritime sciences, talk about the ocean, but also talk about, being on the water itself and sailing. We have motorboats as well. We are primarily focusing on sailing. But let me go to the first question. How can you get the shape of your boat perfect? So, Emmett, do you want to try to answer that question real quick?
Yeah. There's really no way to get the boat exactly perfect. You have to just try your best to get it the best shape it can be.
Yep, and I wanted to just note, first you need to understand, as you listen to Captain Heyman on the video, what the use of the boat is. What do you want to do with the boat, right? So you understand what you want to do before you start to put the design into it. Some of the things we talked about were basics of boat building, buoyancy, right? Hydrodynamics, aerodynamics, right? You saw that also earlier in an earlier video talking about lift, right? So these are all things that are engineering components that come into using boats. And you can even see in the news today, I saw this in today's paper, you saw the Suez Canal, right? We have a boat that got turned sideways in the canal and now it's stuck. It's a huge thing that's happening in the world news right now, right? Talking about people not getting supplies and so forth. This has to do with hydrodynamics. This has to do with aerodynamics and sailing skills. This is the same thing the kids were doing with the small boats on a much smaller level. All the principles apply equally. So it starts with building small boats. Ultimately, the kids are going to be building bigger boats. So maybe next year we'll be showing you that. Well, they're actually building boats where they'll be out sailing on them. But just talking about this one specifically, this one was a nice design. It got modified in the race process. But essentially what they did was that it was tipping and falling into the water because the wind was blowing behind. And so they made an adjustment on site to increase the water line on that side. Whole idea, okay, it's tipping, so the water line is going to be higher. But what that did, though, unfortunately, it also acted as a sail and did the opposite. It actually forced the boat to tip over even faster that next time. Okay, so they added a little, some platforms here to try to keep some stability, but still was not working perfectly. So this is part of the learning process, and this is why we're here, to help these guys understand how boats work. And because it's not just getting out and sailing on them, it's understanding how they work in order to optimize the use of them. Second question, Emmett, do you want to read that?
Yeah. If it is a boat with just a sail and no wind, what will happen? If you're on a sailboat with no wind, you will just be drifting with the tides and current of the water. You'll have no control of the boat.
Right. And so that's a reason that most of our sailboats will have a motor of some sort, right? In case there's an emergency, you don't want to be drifting out of control. So even our tall sail ships, they have a motor inside there. So when needed, we do have some power that we can apply to it. Ideally, in back before motors were invented, right, they were just using the wind itself. And so that's where understanding the currents, understanding the wind patterns, understanding the weather is really important in sailing as well. Okay. And so these are some of the same things. So the boat itself that got jammed in the Suez Canal, they're saying, well, the wind was an issue. Okay. So, these are the things that we need to know and understand as sailors so that we can better be prepared so that we don't get ourselves into a tough situation out in the ocean. And that's what we're teaching the kids as well. And we're also teaching them how to plot courses. We're teaching them how to be prepared for any kind of circumstance that they may encounter out in the water. And the other thing is that we're also a program that's based in helping the kids not only understand the environmental implications and try to help the environmental the situation within the ocean, but also knowing that there is a maritime industry that is based down in that area, that there are some career opportunities in that marine industry. So that's where we're trying to do is work with the youth and trying to get them to understand not only the ocean, career opportunities, and it could even be in a university or within the marine industry itself in shipping or doing whatever they're doing on the water or under the water. And that's also something that we are interested as well, right? Because most of the sea life is not on top of the water, it's actually under the water. So we've got to understand what's going on under the water as well. All right, so I got another question. So, since it's our birthday, what is one good experience from 2020 and one thing you are looking for in 2021? So one of the things that we, of course, encountered with 2020 and having the pandemic was that we weren't able to get together. We just couldn't get together, right? So we had to do things virtually. We were actually on Zoom calls like this, and which everybody was doing, but we had a lot of fun activities, a lot of learning activities. And so we kept the program going, and the kids were coming, and they were even doing fun things with Minecraft, building a ship using Minecraft. They were doing some fun activity games, virtual sailing, but they were also just learning basic things like knots, how to tie different knots and so forth. One of the other things that we've done just recently, and it hasn't been published yet, but we've created a sea shanty. So it's actually a really nice sea shanty that two of our scouts, one did the lyrics, one put the music to it. And so hopefully we'll be launching that sooner than later so you guys can hear the sea shanty called 12 Knots that they put together. But going forward, so that's one of the things but we get together as the different groups, the youth groups get together and compete in competitions. So we're looking forward to that. Hopefully not going to happen this summer still because of the pandemic, but as things get better, we go up to this San Francisco, for example, and we go up there, we have competitions with the other youth groups where they're climbing ropes, they're figuring out how to signal with flags. There's all sorts of competitions. A lot of them are mental, mind-based, and a lot of them are physical, obstacle courses and the like, tying knots and so forth. So we're looking forward to being able to do that again. And definitely we were looking forward to building boats. We want to start to build some opti and laser sized boats where the kids can start to take them out in the water and sail them themselves. And then just to kind of continue to grow the program. It really is based on what the kids want to do. And so that's the whole idea. I think we're going to have a summer camp where we're going to be sailing for about 7 days on the tall sail ships out in the ocean. So that's something that's coming up. That we're looking forward to doing. We get to go out around the islands. People that are listening that aren't from Southern California, we have several groups of islands out in the water, and so we can actually sail and go visit the islands. They could jump, at certain areas where it's safe. They can go swimming off the boats. There's all sorts of things. We can go on shore and do onshore activities. So there's all sorts of things that we're going to be doing, and we're just waiting for the ability to get back out. That's starting to happen. We've been we went to sail last weekend out in the tall sail ship with just our kids. And we have a great crew that's there to support us. And you saw a couple of them on the video that actually basically put that video together. And so we are really looking forward to be able to do that with that group, because there's also a mentorship that goes on between the ship crew and our youth. And that's one of the things that's one of the basis for this program as well. We're here to hear from you. We're here also, if anybody's interested, come down and visit us. Give us a notification ahead of time. Obviously, we've got pandemic protocols that we have to adhere to. We have the three tall sail ships, the Irving and Exie Johnson. American Pride is another one, which is a schooner, so a different style. The Irving, the Johnsons are a brigantine, and they have square sails. So the kids actually can get up there. They furl and unfurl the sails, so they're getting up high into to work within the sailboat. So and then we have a new one that we're working on. It's being retrofitted. It's the Swift of Ipswich, which used to be owned by James Cagney. So if anybody's old enough to know who James Cagney is, he's an actor. All right. How many crew members and kids are on a ship? And what do the different crew members do? I tell you what, Emmett, why don't you go ahead and you want to take a stab at that one?
Yeah. There are around 3 to 4 to 5 crew members on a sail with us to teach us. There's the captain, who calls the orders, knows how to drive the boat, watches out for other boats coming our way to avoid them. There's his first mate, which he tells them to delegate other orders to the rest of the crew, to set the sails, to pull on some halyards.
Okay, and then so basically they're there to operate the ship, right? But we, as the youth group, or if another youth group is out in the ship with the crew, they will actually be given instruction to those youth to actually do the work, to sail the ship. One of the other questions is, do the students or our youth, do they make the sails? So the answer is no, but they have to know how to do what, Emmett, with the sails?
You have to know how to raise and lower the sails and
Right.
tack
You have to
with
operate
the
them.
sails.
But what happens if they do get damaged?
We need to know how to repair the sails. So we have
Yeah,
the
they need
flat
to know how to
seam
repair
and the
them.
round seam that we learn to
Yep. So when you're out in the ocean,
tie holes together in the sails.
right, when you're out in the ocean and something happens, the sails get ripped or damaged, these kids have to know what to do, right? You can't just just keep floating out there with no sails. So they learn how to mend the sails. Okay, so that's one of the things that they do as well. And that's actually a competition. That's one of the competitions when they get together and compete. There's some other fun competitions as well. Emmett, did you want to talk a little bit about some of the other fun competitions when you guys get together?
Yeah, we go to competitions called AMR, Antimony Regatta,
Okay, go ahead, Emmett.
and the Rendezvous, and there we compete with other Sea Scout ships. That competition's about knot tying, sailing, first aid, mariner's quiz, rules of the road, scuttlebutt. We compete with different activities in a competition to see who is the most knowledgeable ship.
Okay. And for more information on that, feel free to contact us. Scuttlebutt's one we could talk about for a while. Actually, it's interesting having to lift a 55-gallon drum full of water up in the air and back down without spilling it. So there's a lot of interesting things that we do, but we're running out of time. So being cognizant of that, we want to just thank everybody and thank Los Angeles Maritime Institute, because they're our sponsoring organization. They are a huge asset to Los Angeles. And once this pandemic starts to get behind us, We're anxious to get the skill kids back out on those boats and get them out in the water. A lot of the kids come in from inner city areas that just don't ever get to see the water, amazingly, even though they live close to it. So we're here as a resource for you.